So with this video, as you can see here, we're going to look at a very brief overview of the nervous system. When we talk about the nervous system, we got to talk about nerves, we got to talk about these things called supporting cells, we got the brain, we got the spinal cord, we have all the nerves of the body. So what video is just going to focus on are the different types of neurons and how we take all the nerves in our body and divide them into different categories. Now, first of all, a few things to keep in mind. Remember, structure determines function, and a neuron is what we call a nerve cell. It's not called a neurocyte, okay, because it's not round, but a neuron looks very, very much like a kite. Because remember, the purpose of a neuron is to receive and transmit information. So it's very much like the antennas that work on our houses to, get our signals or in our radios or in our phones. So with this one, we're going to take all the different nerves and just kind of break it down and look at the structure of the different types of neurons and their function. Now, like I said, a neuron is just one nerve cell. When we talk about a nerve is this organ. So just like your heart's an organ, a stomach's an organ, a nerve itself is an organ. Because remember, organs are groups of tissues that work together. And a nerve, like your optic nerve, which is responsible for your sense of sight, it has nervous tissue, which is neurons. It has connective tissue, which are membranes and blood. It has epithelial tissue, membranes that are surrounding it. So you'll hear me use neurons and nerves interchangeably, but please make sure you understand the difference. A neuron is one nerve cell. A nerve is an organ that will contain hundreds to thousands of neurons. Now, when we look at all the nerves in your body, we take them and we kind of divide them into two main categories. We have what we call the central nervous system, and we have what we call the peripheral nervous system. Now, the central nervous system is just your brain and spinal cord. So any nerve that's in the brain or any nerve that's in the spinal cord is part of your central nervous system. That's it. All the other nerves of your body are part of your peripheral nervous system. So I need to make the distinction between a cranial nerve and a spinal nerve. Okay. You have brain nerves and you have cranial nerves. Okay. Brain nerves are nerves that are in the brain, so they are part of your central nervous system. Cranial nerves are 12 pairs of nerves that attach to the brain. And later on, we're going to talk about the 12 pairs of cranial nerves and what they do. But your cranial nerves are not in the brain, so they are not part of your central nervous system. They are part of your peripheral nervous system. Likewise, your spinal nerves are not in your spinal cord. They attach to your spinal cord, so they are part of your peripheral nervous system. So when we look at all the nerves of your body, in the case of your nervous system, okay, we have, I'm just going to put nerves here. My handwriting is not the best on here. And so we take all the nerves of your body and we divide them into two groups. You have the CNS and you have the PNS, your central nervous system and your peripheral nervous system. The central nervous system is just the brain and spinal cord. Your PNS are all the other nerves that you have in your body. So with the central nervous system, again, just the nerves of the brain and the spinal cord. And I'm going to have another video later that talks about the brain and the parts of the brain and the spinal cord. And the peripheral nervous system are all the other nerves of your body. And we take those and we divide them up into two more groups and even more and even more and even more. But just keep in mind, do not get the cranial nerves and the brain nerves mixed up and the spinal nerves and the spinal cord nerves mixed up. Okay? Brain nerves are actually nerves in the brain. So they are central nervous system. The spinal cord are nerves in your spinal cord. That's central nervous system. Cranial nerves are 12 pairs of nerves that attach to the brain. So they are peripheral. And your spinal nerves are 32 pairs of nerves that attach to your spinal cord. And they are what we call peripheral nervous system. Now, you obviously have a lot of peripheral nerves. So we take them and we divide those into two different groups. We have what we call the somatic nervous system, and we have what we call the autonomic nervous systems, which I'm getting ready to talk about on the next slide. And keep in mind, a nerve is an organ. And organs are groups of tissues that work together. And in the case of a nerve, we have two types of nervous cells. We have the neuron, which is the actual cell that makes the electricity. And then we have things called supporting cells or glial cells. These cells do not create electricity, but the neuron cannot work without their help. So the central nervous system is the brain and spinal cord. But what we're going to focus on in this slide is your peripheral nervous system. And the peripheral nervous system are basically all the other nerves of your body. So we have the peripheral nervous system. And with the nerves in our body, one of the ways that we can classify nerves is based on their jobs. And so with your peripheral nervous system, you have what we call sensory, and you have what we call motor. Okay. Now, sensory, sorry for my messy handwriting. Sensory deals with your senses. So a sensory nerve or a sensory neuron's job is to gather information from the body and the environment and send it to the brain. So something like your optic nerve would be a sensory nerve. Your olfactory nerve would be a sensory nerve. Your stomach has to tell your brain whether it's full or empty. That would be a sensory nerve. So when we talk about sensory nerves send information up to the brain. Motor nerves are nerves that tell the body what to do. So you can think of sensory nerves as information going up towards the brain, and that's how the body talks to the brain, or that's how the brain gathers information. But then the brain needs to tell our muscles what to do. Your brain has to talk to your cardiac muscle, it has to talk to your smooth muscle, it has to talk to your skeletal muscle, it has to tell your body what to do. So when you think of motor, you think of movement. And so motor neurons are going to carry information from the brain and spinal cord to the different parts of the body. So with peripheral nervous system, we can take these nerves and divide them into two groups. Sensory, which gather information and send it to the brain, and then motor, which takes that information and sends information to the body to tell the body what it needs to do. So in the case of motor, we have two categories of muscles in our bodies, if you remember. Muscles are voluntary, which means they're controlled by the cerebellum, or they're involuntary, which means they're controlled by the cerebrum. So in the case of our motor neurons, we take them and we divide them into two groups. Our motor neurons can be part of our somatic nervous system. They can also be part of our autonomic nervous system. Now, in the case of somatic, our somatic nervous system controls our voluntary muscles. Okay? So this is responsible for voluntary, right? Which means this is a part of your brain that controls your skeletal muscles. This is from your cerebellum. So somatic is voluntary muscle movement. So that's going to be your skeletal muscle. Obviously, autonomic looks like automatic, so that's going to be involuntary muscle movement. So this is going to be, I'm just going to put involuntary, and so this will be cardiac and smooth. And again, sorry for my messy handwriting, it's just hard to do on this computer screen. But with automatic, we have cardiac and we have smooth. This is controlled by the part of your brain called the cerebrum. So your peripheral nervous system are all the extra nerves, all the nerves that aren't in your brain and spinal cord. If you're a sensory nerve, you're going to carry information to the brain. If you're a motor nerve, you're going to carry information from the brain. So you're probably going to a muscle of some type. In the case of the somatic, you're going to a skeletal muscle. So you are voluntary. In the case of the autonomic, you are involuntary. So we're going to the cardiac muscle or we're going to the smooth muscle. Now, in the case of the autonomic nervous system, we have two divisions of this as well, because our bodies work in two patterns. Okay? We have two divisions, if I can get this to erase, of the autonomic nervous system. And with the autonomic nervous system, we have what we call the parasympathetic nervous system and what's called the sympathetic nervous system. So I'm just going to put autonomic here, if I can get my pen to work again. Okay. I'm going to put a big A. And with the autonomic, we have what we call the parasympathetic nervous system. and what we call the sympathetic nervous system. In the case of the parasympathetic nervous system, these nerves control our bodies in what we would consider normal conditions. So normal heart rate, normal breathing rate, what we can call our body just working under normal conditions. The sympathetic nervous system kicks in when our bodies are under times of stress. And times of stress do not mean that you're stressed. It's just, it could be that you're excited. It could be that you're nervous. It could be that you're upset. It's when your body isn't working in its normal capacity. And so we're going to look at these in a little bit more detail in the next slides. So like I mentioned, the nerve is an organ. And so nerves they're made up of neurons, which are the cells that actually make the electricity, and these things called glial cells, which are also called supporting cells. Glial cells do not make electricity, but they do help the neurons do their job. And like I mentioned, we can classify neurons based on what they do. I've already talked about motor neurons and I've talked about sensory neurons, but then we have one that's called interneurons. If sensory neurons take information to the brain and motor neurons take information away from the brain, there has to be something in between them. There has to be something that figures out, okay, here's all the information I just gathered. What do I need to tell the body to do? And these are what we call interneurons. They're also called associated neurons. So motor neurons carry information away from the cell body or the brain in order to tell muscles what to do. And sensory tells the information, gathers information, and sends it to the brain. And so nerves in the brain and spinal cord that are the go-betweens are what we call interneurons. We can also classify a nerve or neurons based according to their poles, which we're going to get to in a second. So in the case of a neuron is a nerve cell. And remember, structure determines function. So cells have different jobs, they're going to have different shapes. A neuron is often drawn looking like a kite. It has this one end that has all these different streamers coming off of it. That's where the information gets collected like antenna. And then it has this long cord that electricity passes down in order to take that information somewhere else, just like you have a cord of an appliance. Now, when you look at a neuron, the part of the cell that has the nucleus and the mitochondria, that's what we call the cell body. Okay, that is the main part of the cell. And coming off the cell body, you can see these cords. Okay? I think of them as antenna. These are what are called dendrites. Dendrites gather information. So every neuron will have lots and lots and lots of dendrites because they need to soak up as much stuff as they can. Okay? These are your antenna. It's better to overgather than it is to undergather because neurons have to reach something called a threshold. A threshold is what does it take to turn the neuron on? What does it take to start making electricity? So for example, right now, the cones in your eyes are being heated up by light. When they heat up enough, they flip the switch, they turn on, they create electricity, it goes to your brain, you can see. Right now you're hearing my voice. You have little hairs in your ears that are vibrating, and those hairs are attached to a nerve. When they vibrate enough, the nerve reaches threshold, it flips the switch, it turns on, it creates electricity. So every neuron is going to have a lot of dendrites because they want to gather as much information as possible. The dendrites then take the information to the cell body, and the cell body kind of weed out, okay, what's important and what's not, because you don't need everything that you gather. You have to learn to ignore some things, just like you ignore the fact you feel your clothes up against your skin. Now that I've mentioned it, you can feel it, but that's a different story. It then, once the neuron, the nucleus figures out what's important, it has to send that information on. And it's going to send the information down this cord, and this cord is called the axon. Now, every neuron will have lots of dendrites, but every neuron only has one axon. And the region where the axon branches off of the cell body is called the axon hillock. Now, the axon has a lot of electricity in it. So we need to insulate it, just like we insulate all the cords on all of the appliances and lamps and things that we have in our house. And this layer of insulation is called myelin. Now, myelin is a fat. Something has to make fat. So we have little cells called supporting cells. They're called glial cells, And these cells are called Schwann cells. And Schwann cells basically spin around your axon and secrete fat. So this would be a Schwann cell right here, a Schwann cell, a Schwann cell, a Schwann cell. And they spin around and they deposit these layers of fat. So we have these little bubbles of fat, and that's what we call myelin. Now, since each cell is creating its own bubble, the bubbles aren't attached to each other, but we have this gap right here. And this gap is called the node of Ranvier. And it's actually very helpful. A lot of neurons are really, really, really long, and they can't rely on getting nutrients through diffusion from the cell body. Yeah. If the nutrients were coming down, and this was really, really, really long, the nutrients would get used up. So little capillaries can pass through these little gaps in order to provide the axon with nutrients. So like I mentioned, the cell body is what contains the nucleus and other organelles. The dendrites transmit electrical impulses to the cell body. They gather information. The axon transmits impulses away from the cell body. It's like the cord that's carrying the electricity. And the axon hillock is where the axon comes off. Now, the axon will then branch. Just like if you look at the plug on an appliance, it tends to have 2 or 3 branches. Well, your axon is also going to branch. That way one neuron can carry information to a lot of cells at one time. And where it branches, this is called the axon terminal because it terminates. It's also called the collateral. Now, the ends of these axons have bubbles. So the axon will then branch, and they have bubbles on the end of them. And those bubbles are called boutons. And think of boutons as water guns. They contain hormones. Now, hormones are how cells talk to each other. We don't want electricity jumping from cell to cell because it's just like, I'll shock you. You'll shock those cells. So electricity will hit this bubble, and it's like you telling your finger to shoot the water gun. And so when the electricity hits these boutons, they open out and they shoot a chemical out, and that chemical is a hormone. Now, this hormone is called a neurotransmitter because it's transmitting information from the neuron. Because remember, neurons can't touch other cells, so they shoot out hormones. So basically, if I were one neuron and you were another neuron, there would be a space between us. And you're sleeping and I have to wake you up, so I'm going to shoot you with really, really ice cold water in order to get a reaction. Now, like I mentioned before, we do have myelin. Myelin is a fatty substance wrapped around the axon, and myelin is made by a group of cells we call oligodendrocytes. Now, here's a little fact. Your dendrites are not insulated because fat does not absorb. And the job of the dendrites are to vibrate, to absorb chemicals, to absorb heat, so that we can reach threshold, we can flip the light switch and start to create electricity. Well, oligodendrites are a group of cells in our bodies that secrete myelin. Schwann cells are just one kind of oligodendrocyte. But you will hear me not using the term oligodendrocyte because it makes you think that it's putting fat on the dendrite. The only part of the neuron that has this layer of fat is the axon. Okay. So oligodendrocytes, Schwann cell is just one of many different types of oligodendrocytes in our bodies. And these are examples of what we call glial cells. And like I mentioned, we have gaps, and these gaps are called the nodes of Ranvier. And these allow nutrients to reach the axon along the way. Now, you've all heard of white matter and gray matter, probably when people talk about the brain. Well, myelin, you've all seen bacon grease before. Okay? Natural butter is white. Okay? Companies add yellow to the yellow food coloring to butter. But if you actually go to a farm that freshly makes the butter, it's white because butter has a lot of fat in it. Fat is white. And so the more myelin a neuron has on it, it's going to have a white color. And so the more myelin a neuron has, the more electricity that neuron is making. So a lot of our really, really, really important nerves, they create a lot of electricity. They're going to have a lot of insulation. So they're going to be white in color. So like our really important nerves in our brain are buried down deep inside of our brain. And so if you cut the brain open, you'll see a color change. And so this is what we call white matter. Nerves that aren't as important, or they don't make a lot of electricity, don't need a lot of myelin, so they tend to be gray in color, and that's why it's called gray matter. Now, I mentioned how we can classify neurons based on their jobs. You're a sensory neuron, you take information to the brain. You're a motor neuron, you carry information away from the brain. Or you're an interneuron, you're a nerve actually in the brain or spinal cord. We can also classify neurons according to their poles. Now, in the case of a neuron, every neuron has lots and lots and lots of dendrites to gather as much information as possible in one axon. Now, where these branch off of the nerve, that is considered to be a pole. So for example, I have a pole here, 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 and here. Okay. Those are all what we call poles. So it's not how many dendrites you have, because every neuron has a lot of dendrites, and every neuron will have one axon. It's where do they branch off. So this is the most common type of neuron we have in our body. This is what we call a multipolar neuron, because this one has 1, 2, 3, 4, 5, 7 or 8 poles. Now, we also have what we call bipolar. Okay. Now, this one here is bipolar. You can see we have 2 poles, 1, 2. There's only 2 sections coming off of the nucleus. Bipolar neurons are found, the rods and cones of our eyes are bipolar. Okay? And in the case of multipolar, you can see here they have lots and lots and lots of dendrites. This is like your sense of smell, your sense of taste, your sense of touch, your sense of sound. This is so that you can gather, it's like having lots and lots of antennas. But in the case of our eyes actually, the lens of our eyes actually takes the light like a laser beam and can direct it just to one spot. So that's why we don't need this big fuzzy like dandelion puffball of dendrites, because the light gets focused right to where it needs to go. We also have what we call pseudounipolar or unipolar. Notice there's only one branch there. In the case of unipolar, this allows the electricity to totally bypass the nucleus. You know, here, information has to go from the dendrites to the nucleus and then down the axon. It gives the nucleus a chance to figure out what's important and what's not. Well, in something like a reflex, reflexes use unipolar neurons. With a reflex, you don't have time for your brain to figure out what's going on. If I throw something at your face, you don't have time to say, oh, that's a brick, or oh, that's a cotton ball, because it will have hit you before your brain figures out what's going on. So reflexes are protective measures we have. Reflexes use unipolar neurons. It allows them to bypass the nucleus. So we actually react before we think. Okay? So again, if I were to throw something at you, you would react and then you'd be like, oh, that was just a cotton ball. Because with unipolar, with reflexes, we're protecting our bodies, so we need very, very, very fast reactions. Which then leads us to the last 3 slides, which talk about glial cells, or what we call supporting cells. Okay. The neuron is what actually makes the electricity. Glial cells do not make electricity, but they are part of nervous tissue, and the neuron cannot do its job without them. So like we've already mentioned, Schwann cells are types of oligodendrocytes, and these produce myelin. You guys know you cannot take a cord in your house and scrape the rubber insulation off of it. It will short circuit. It will cause a fire. Well, we can't short circuit our nerves either, because if our nerves short circuit, remember, nerves don't repair themselves. Once it's gone, it's gone. And we also can't risk burning other cells around that area of electricity. We also have things called satellite cells. Now, just like satellites go around the world, we have small phagocytes. Phagocytes are cells that basically eat trash, that make sure the dendrites stay clean. If you think back to that picture of a multipolar neuron, It's like having a head of hair, and you wash your hair to keep it clean. Well, dendrites act as filters. Stuff can get trapped in them. And just like you have to change the filter in your air conditioning system, because if it gets too full, air can't pass through and your air conditioning is not going to work correctly. If the dendrites trap too much trash, they're not going to be able to do their jobs like they're supposed to. They won't absorb what they need to absorb, or they won't vibrate like they need to vibrate. So the satellite cells are like vacuum cleaners. Or like the shampoo that we use to wash our hair. They're going to help keep dendrites clean. We also have astrocytes, which get their name because they're star-shaped. Astrocytes form what we call the BBB, the blood-brain barrier. And this is found in our brain and spinal cord. And with the blood-brain barrier, the BBB, if you have your brain, okay, you will have the blood vessel that's taking nutrients to the brain, and in between them, you will have this layer of astrocytes. And that's what we call the BBB, the blood-brain barrier. These are cells that help make sure that nothing toxic gets into our brain tissue. So everything must move through the brain by diffusion and active transport, and most substances cannot pass through the layer of astrocytes through diffusion. So it gives the astrocytes to figure out, is this substance something that's okay to touch our brain tissue? Now, last thing, however, like I mentioned, neurons cannot touch another cell. Electricity is an electrical impulse is information getting passed on from one cell to the next. But only the axons are insulated. So what you're seeing here in this picture, this is the Buton. That's the water gun that contains all the chemicals. And this is whatever cell it needs to talk to. It might be another neuron, it might be a muscle cell. But you guys know it hurts when you get shocked. When electricity touches you, it hurts. So we can't really let electricity touch the other cells or it can damage them. So we have a gap between the cells, and that gap is called the synapse. Now, what happens in most cases, we have two types of synapses, an electrical synapse and a chemical synapse. Now, electrical synapses are rare. Okay? These are found in reflexes. This is where electricity is actually allowed to jump the gap. So it's very, very, very fast. So you basically allow electricity to shock the next cell, and this is a quick way of passing information around. And again, this is very rarely used because it could damage the other cells. But if you think about it, we don't use reflexes that much. Most of our synapses are what we call chemical synapses. These use neurotransmitters made by the Butons. So again, think of a Buton as being a water gun. If I'm one neuron, you're another neuron. There is a space between us. Okay? You're asleep. I need to wake you up. I can't talk to you. Nerves can't speak. So when electricity hits the Buton explodes open and shoots out ice cold water. That ice cold water is the neurotransmitter. And that ice cold water is going to hit the next cell and wake it up. So it'd be like you sleeping. If I were just to take like a little drop of ice cold water, it wouldn't wake you up. But if I dump a huge bucket of ice cold water on your head, you're going to wake up. And this is how most neurons pass information from one cell to the next.